It's 6.3. We're going to talk about these three objectives for today. We're going to calculate the mean and the standard deviation of a sampling distribution. And we're talking about basically proportions in this today. So we're not talking about mean or minimum or other types of statistics. We're going to basically talk about proportions today. So we're going to calculate the mean and the standard deviation. We're going to determine if that sampling distribution is approximately normal. And then if it is approximately normal, we're going to use the normal distribution we did in Desmos to figure out certain probabilities. Those are our three things we're going to do today. So let's start with this example. So let's say that we have a bunch of flash drives. There's a shipment of 10,000 flash drives, and we know that 2% of them are defective. They're no good. 2% of them. Okay. So 0.02. There's our proportion idea. Okay. Now, they want to take a sample. So this is our population, right? We want to take a sample of 10 flash drives, and X is going to be the number of flash drives, defective flash drives in the sample. Okay. So if we think back to last chapter, remember if something is binomial, we know that it has to fit bins, right? Okay, so does this fit bins? Okay, so either they are defective or not defective. Independent, we're not going to worry about that for right now. We're going to take a sample of 10 flash drives, and the probability that they are going to be defective is 2%. Okay, so it's binomial. Now, in binomial from last chapter, the way that we found the mean, remember the formula? The mean is n times p. Okay, and our standard deviation, our formula for standard deviation was the square root of n times p times 1 minus p. Okay, so that's how we're going to find our mean and our standard deviation. Okay, so in this particular problem, our mean, okay, would be we're taking a sample of 10 flash drives, and 2% of them are bad, right? So that comes up to be 0.2. And our standard deviation would be 10 times 0.02 times 0.98. And that comes up to be 0.44. Okay? So we would say in our interpretation, in our sample of 10 flash drives, we would expect an average of 0.2 defective drives. Okay, so that's it. And then we would expect they are typically, what do I say? Typically vary. Number of defective drives, the number of defective drives typically varies from 0.2 by 0.44. Okay, so that's our standard deviation. Okay, so we found our mean and our standard deviation. Okay. Now, let's talk about shape a little bit. Okay, so in that particular problem, we had 10 trials, right? We're taking 10 flash drives, and the probability is 0.02. Now, if you look at this distribution here, it's very much skewed to the right. Okay, the red here is a normal curve, so it doesn't really fit the normal curve at all. Watch what happens when I take the number of trials and increase it. So instead of taking 10 flash drives, I take 13 or 18 or 20. What do you notice is happening? Okay, so notice that the curve, I wish I could zoom in on it a little bit more, the curve becomes more normal the more trials that I take. Okay, and actually let's get a better view of it. Let's take this up here a little farther. So let's say I take a probability of 0.2 instead of 0.02. Okay. So if I take just a small number of trials, once again, skewed, right? Not normal.
Okay, but the more that I take, the more normal it becomes. Okay, the better that it fits under that normal curve. Okay, so we can say it's approximately normal if we get to the point where it fits pretty well. Okay, and the idea of what we need is we need the number of successes and the number of failures to be at least 10. And if we have that true, then I can say it's approximately normal, and then I can use a normal distribution on Desmos. Okay, go back to the other video.
Okay, so we saw in that other video that as you got more and more in our sample, instead of just 10, if we got more and more in our sample, it becomes more and more normal. Okay, so for it to be approximately normal, we need the number of successes and the number of failures that we're expecting to happen to be at least 10. So the number of successes, the number of defective parts was n times p, right? Okay, so we need our n times our p to be at least 10. And the number of failures would be the opposite of this, right? Opposite 1 minus your p. We need that to be also greater than 10. If both of these things are true, then we can say our distribution is the shape of the distribution is approximately normal. Okay, so let's look at an example. So if I take this example here, suppose that 12% of teens in a large city have a credit card. X is the number of teens with a credit card in a sample of 500 teens. So I'm going to take a sample of 500 teens. Would it be approximately to use a normal distribution? Okay, so in this particular problem, I have to test this, right? So our n is 500. There's 500 teens. And the probability they have a credit card was 12%. And the probability they don't have a credit card would be 1 minus 12%, which would be 88%. Okay, now if I multiply these together, 500 times 0.12 gives me 60 people. I would expect out of 500 teens, I would expect 60 to have a credit card. And I would expect 440 to not have a credit card. Okay, since these are both greater than 10, therefore I can say this distribution is approximately normal. Okay, so I know I have a approximately normal curve here. Okay, now I know the mean. Okay, we talked about mean and standard deviation up here, right? How to find mean and standard deviation. The mean of this curve is n times p, which we found here, right, was 60. So our mean is 60. And our standard deviation would be this, right? So if I take 500 people, probability of 12, and 1 minus 0.12 is 0.88, right? So if I figure that out, I would have a standard deviation of 7.27, okay? It means if I add and subtract, remember the three things we get there, we get our normal distribution with this mean and this standard deviation, okay? So that is the second step, okay? So step number 1 we learned today is how to find the mean and the standard deviation. Learning objective 2 is how do we decide if it's approximately normal, okay? Learning objective 3, this is going to be easy if you get this other stuff, okay? Is then we're going to, if I know that it's normal, approximately normal, with this mean and this standard deviation, we can use normal distribution on Desmos, okay, just like we did last chapter to find the probabilities. Okay, so let's do this problem right here. One way of checking the effect of undercoverage, non-response, and other sources of bias in a sample is to compare that to known facts about a population. For example, in the United States, about 12% of the people identify themselves as black. suppose we take a sample of 1,500 American adults. How many would I expect to be black? Okay, X is going to be the number of these that I expect to be black. Okay, so if I find the mean, my mean is N times P, right? So I'm taking 1,500 people, 12% of them are black, gives me 180 people. So I would expect an average of collecting this many in our sample, 180 people that are black in that sample. Okay, the standard deviation be the square root of 1,500 times 12% times 1 minus 12%. And that gives us a standard deviation of 12.59 people. Okay, so we have that. Now, so that's learning goal number 1. Learning goal number 2. What is it approximately normal? Okay, I need to know N times P and N times 1 minus P. I need to find those, right? I already did N times P was 180. I would expect 180 people to be black out of the sample. And I would expect 1,320 to not be black out of this 1,500. So you can either take 1,500 minus this 180, or just do N times 1 minus 12 is 88% of them, right? So, okay. So since both are greater than or equal to 10, I know it's approximately symmetrical. Okay. So what I know now, I know it's approximately symmetric. I know my mean is 180. And I know my standard deviation is 12.59. Okay? Now, here's the last part of it. Calculate the probability that if I have a sample of 1,500, which I have here, that it will contain between 155 and 205. So between 155 and 205 blacks. So we want to know this probability right here. So if I take a sample, what's the probability you're going to have that between that many blacks in this sample? Okay, so we would go to the normal distribution on our and I'll show you that in Desmos here in this other video.
Okay, so we're going to go and use the normal distribution like we did last chapter. Okay. So we go to functions, distribution, it's a normal distribution. We said our mean was 180 people with a standard deviation of 12.59. Okay, so there is our approximately normal distribution graph. All right, now we want to know between 155 and 205. So if we go to find the cumulative, between 155 people and 205 people gives us a probability of 95%. Okay, so that's how you find the probability.
Okay, so we had said that there's a 95% chance, like based upon what we know about the U.S. population. If I get a sample of 1,500 people, and I have between that many and that many people, black people, there's a 95% chance of that happening. Okay. Now, what if they get results? What if they only get 100 people, okay, in the sample that are black? If I only get 100 people that are black, that probably tells me that I have a lot of undercoverage. There should be a lot more black people in this survey to make it an accurate representation of all the people in the U.S. Okay, or if I get 300 black people out of the 1,500, that means I probably is biased in some way because I'm getting more blacks than I really should according to the population percentages. Okay, so we did 3 things today. What we learned: how to find the mean and the standard deviation, how to know if it's approximately normal, and these both have to be greater than or equal to 10, and then how to find the normal probabilities using Desmos.